Alright guys, welcome back. This challenge was different regarding to the ones we faced so far. Because now you've got several options, things you have learned in the past. So it was not regarding to a special topic, it was regarding to what we have learned so far. This makes it of course harder, and in case if you struggled a little bit, don't worry too much about this. We will take a look together into this right now. And afterwards I'm pretty sure that you understand the whole application function and how you can patch this the next time on your own. In case, of course, if you have successfully patched this, congratulations. This is a real-world application example, and I have encountered this many times in applications regarding to different types of customers. So therefore, you successfully bypassed a real-world routing detection, which is really amazing. So whatever which case we have right now, let's take a look into this together. So I still got it open here, and let's grab this application. Downloads, root check, and put it into a new app directory. Alright, so let's have a look first with JDX GUI. Okay, so here we have the main activity. Let's see, we've got some Android stuff and text view and button. We've got an if statement over here, root util, is device rooted. This sounds very promising. Then we've got some stuff, the device is rooted. So we know regarding to the text, this one is our, this is the state we do not want to have. We want to have this one over here, because here we will return out of this method, out of this function, so we leave this application. Okay, so now we know what we're dealing with. Regarding to this one over here, let's see if we can already patch this without taking a look into the routing detection. I get out my graphic tablet and then we discuss this, okay? And let's go. Okay, here we are back again. Let's have a look into this. Alright, this one is our if statement in this line. So if we go into this function, we've got a lot of instructions, but here we leave this function. So this one is our exit, and we do not want to go into this. So let's recap this real quick, what we have learned in the last couple of videos. Let's say we get rid of this instruction over here. We patch this or delete this if statement. Does this brings us anything further? Let's have a look. So let's say this one does not exist anymore. Okay, then we've got a regular instruction, another one, but at this point we are still leaving. So this doesn't bring us that much until we also delete the return statement here. If we delete this one, then we have some other additional instruction. This one, and this one. Yes, that's missing. Alright, this means we are having a device which shows, this device is rooted. But we are also having a device which says, everything is fine. So by having these two states, we got our task done. But in my opinion, this is not a really clean solution. Because if we do not patch this if instruction over here, this one, and just delete it, the device still gets flagged as being rooted, and this will mean that some features might not be possible to use in this app. Of course, in this activity it's fine, but maybe regarding to other services we might encounter some trouble. Therefore, this is a nice approach, but not the solution. If you want to, you can try this to get rid of the return statement and also of the if statement there and see how good it goes. But now I will come to the real solution, okay? So let me clean the screen real quick. Alright, and now let's have a look into this. So this is our routing detection. Let's see how it works. I click into the class and here we go. So first of all, I want to thank and mention the author of this. I will blend it in right now. So this routing detection is working absolutely fine. There's no problem within this routing detection. It protects the user from running an application on a modified smartphone. but still as an attacker we need to patch this. So let's have a look how it works and how we can circumvent this. Okay, the first one sounds pretty promising. So I get back my pen, there we go. The first method is device rooted? And let's have a look at the function itself. We do not have any parameters here and we return a Boolean value, this one. Okay, that's pretty interesting. Let's see how it looks internally. So let's clean this. Okay, so we are returning this method or the value of this method or the value of this method. Whoops. Or this method. There we go. Okay, so this sign means an OR statement. What does an OR statement do? And let's see. We've got this following binary table. So we've got A and B. And this one is 0, 1, 0, 1, and A is 0, 0, 1, 1. So if we combine them with an OR, then we get the following result. 0 and 0 will be 0 regarding to an OR statement. 0, 1 will be 1. 1 and 0 will be also 1. And 1 and 1 will be also 1. This means if one condition is set to 1, then the output will be 1. Otherwise, if both are negative or false, then the output will be 0. Alright, regarding to our routing detection, this means if one of them returns true, so 1, then the whole function here will become true. So this Boolean value here will become true. This is pretty neat for the routing detection because let's have a look into this. For example, the first method, check method 1. Check method 1 checks if we've got test keys enabled in a build tag. Okay, whatever this means. If we have here a true statement, we do not need to go into this and this to flag this device as being rooted, because one true statement here is enough to make the whole output being rooted. This means if the function here returns 1, we get a true, and this means the device is rooted. If this function returns a 0, which means false, the device is not being rooted. Okay? So let's see, how can we get a 0 and false statement? Well, we have to be, or all three methods, so in this case we also have a method C, and also this method C needs to be 0. Okay, so let me clean this up real quick and then we go into the functions in detail. Alright, so we are having three methods. Each of them returns a value. And if one of these values is true, we lose. Or let's say I lose, because it's not your fault if I do not bypass this, okay? Alright, let's have a look into the first method. The first method checks if we've got some build tags with the test keys enabled. So if this is the case, we are returning true, otherwise we are returning false. Okay. Next, we've got this one here, check method 2, this. And this checks if certain applications are being installed. For example, the super user, the SU binary, and yeah, other stuff. If one of them is installed, the device, the path exists, it will return true. So there we lose, or let's say I lose. And if it's false, we win. False means none of these binaries or APKs has been identified on the system. Last but not least, we've got check root method 3 and and this method executes a system command, which means we are checking if the SU binary exists on the system. So these are our three routing detections. And if one of them becomes true, then the whole device is being flagged as rooted. Okay, so one approach would be to patch all of these three methods over here. So instead of returning true, we can go into this and return false. But we have to do this for all methods. So also here and also here. By doing this, all of them will return false, which means if we combine 3 false together, the output will be false regarding to this OR statement over here. And this means our device is not rooted. Okay, this is a valid approach, but it requires a lot of effort. And we are super lazy hackers, therefore we want to take the path with the least resistance, like the electronic stuff does. So what other options do we have? Let's clean this up. Instead of patching all of them, we can go for the master routing detection, which is this method over here. This method checks all 3, and afterwards it returns true or false if the device has been rooted. So by patching this method over here, we can simply say always return the value false. So regarding to this challenge, I would recommend you to go for this part. Simply patching it at this point by adding a new const value regarding to the register that's being returned and set it to false. Alright, you can now pause and rewind this video in case you want to try this out. I will move on with the real challenge and here provide the solution for this. Okay, here we are back. On the left we've got the Smali code and on the right we've got the decompiled Java code. Let's have a look into this. We've got our file root_util, this is our class. We do not extend a certain special class, it's just Java-Lang object. This is our file name, okay. Then we have the constructor. And here we can see check root method 1. Okay, if we take a look at the right, we can see, oh, that's strange. Because here we have is device rooted. But yeah, this one seems to be missing right now on the left. And this happens quite often in Smali. You can check this if you click left into these line numbers. So here you have your line numbers regarding to your Java code. And if you click left with the mouse button, then you can see the line numbers regarding to the Smali code. And here we can see those line numbers are increasing. But here we have some strange looking. So we are having 32, 37, 32, 30 back again. So the Smali code is a little bit different regarding to the order than the Java code. We have seen this in the if statements. The compiler has produced a different order which is faster for the CPU to execute instead of going the Java approach, so the Java order of this code. Alright, but this is not a big deal. We have seen this in the past and we can handle this. So we just need to navigate around with the Smali code and we have to trust the Smali code on this. Okay, we can see this one is check root method 1. This one over here. And let's go down. Here we have check root method 2. This one over here. Then we can see all those strings and binaries that's getting checked. We go down. Here we have check root method 3. Alright. If we go down. There we go. At the end we've got is device rooted. Alright. And we can see this over here. Line 10. This is line number 10. Okay, it's at the end of this file, but I mean, who cares? So we have found this and let's analyze this and try to patch it. So the first one is a new instruction and we haven't talked about this yet. But if you take a look at the Smali instruction that exists, so I hope you have your cheat sheet prepared, you can see we cannot talk about all of them. But we have learned a lot of things about Smali and maybe we can apply this knowledge in reading and also understanding what this instruction does. So let's have a look. This instruction is named invoke static. So copy. So now we are searching for this. Alright, invokes a static method with parameters. That's all. It just invokes the method. It doesn't do anything more. Okay, let's see. Which method? Let's have a look. So I enable my pen. And we can see we've gotten capital L. This means we're having a class reference. The class reference ends at the semicolon. So we are dealing with root util over here. We are having root util. Okay, then we've got this arrow, which means we are having a dot, and after this dot, we've got the method name. In this case, check root method 1. And so on. And we can also see the return type of this is Boolean. Okay, so we do not know, or we didn't know what this one does. But now we know this one executes this method call. So regarding to static methods, we do not have to create a new object. We can simply use the class and then the method name to invoke this. Okay? So this one is just executing this function, but it doesn't do more. So therefore we have this next line. This one moves the result into v0. But nevertheless, let's verify this because we are not familiar with this. So let's see. Move result. Move the result values of the previous method invocation into Vx. All right. So the return value of the previous method, which is this one here, gets now moved into v0. This means our v0 is now being true or false. Depends on what the return value of this method is. Which means we are having 0x1 for true and 0x0 if we've got a false. Okay, then let's have a look into the next one. Nice, an if statement. So, if v0 is not equal 0, let's write this down. Yeah, I enlarge this and we write this next to it. Yeah, it still fits, nice. So, at this line, if v0 is not equals 0, we jump to this condition. This means if our v0 is set to true, because then we are having a 0x1 in there, we jump to condition 1. And if we look at condition 1, let's see, here's the label. Okay, so we are jumping down there. And then we are writing 0x1 into v0, which is interesting because v0 is still set to 0x1, but nevertheless. So v0 is 0x1, that's what this line does. And then we are returning back this v0. Okay, this means our method will return true because this one is set to true. It means our routing detection is being set to true and therefore our device is rooted. So let's take a look at the code once again to verify if everything is correct right now. We've got a Boolean, is device rooted? Is device rooted true means our device is rooted. And if this method returns true, then the whole method returns true, which means our device is being rooted. So we can also circumvent this right now by patching this if instruction. So we can flip the logic of this. So here we get an additional patching option. Instead of going for this one over here at the end, we can also flip the logic over here. But we need to take care about this because in our case, this method will return false. So this doesn't flag our device as being rooted. If we now start flipping the logic, this method will tell that our device is rooted, even if it's not the case regarding to this check. So this is something we need to consider. All right. So therefore we do not go for this one. Okay. So let's clean this up a little bit and then we do the next check. So we've got the false statement for this one over here. Okay. So if this one is false, which is the case by the way for our routing detection, and therefore by flipping the logic this will become true, we will end up with a rooted device, Therefore, we do not, or flipping this logic here will not work for us right now. Okay, but if it's false, we go into the next one. And here we have check root method 2. We've got the same approach like this one here. So we have our class root util dot, let's write it in this way, dot check root method method 2 returning this Boolean value. This Boolean value gets stored into v0 over here, and we can see the same approach. So also right here, if v0 is not equals, if v0 is not equals 0, we jump to this condition. And our v0 is the output of the one before. So, the one before is only this and this line. So v0 is equals to, let's write it down, root util dot check method. Okay, there we go. It's getting a little bit, messy, but I guess we can follow on this. Okay, so this one is this over here. We are still using the v0 register, and if this one is not equal 0, we jump to condition 1 back again, which is this one here. And here we set our v0 to 1, and then we return v0, which means we are having the same case. Let's do this once again. So if our v0 is not equal 0, means our v0 is 1. Then our v0 will be set to 1, okay. And then we are returning 1, okay, which means we are returning true, which is not okay, because then we know our device is rooted. So this method also needs to return false. Not also. This method needs to definitely return false. So regarding to the patching approach, we can flip the logic over here. This will work, because if you take a look, we can see this method will definitely flag our device as being rooted, because we have the SU binary on our device. We might also have the super user APK, I'm not sure, but one of these will definitely be true. Therefore, this method will return true. So let's toggle the visibility. Okay. I clear this up real quick. So this method here returns false for our case, that's okay. But this one here will return true. And therefore, we can flip this logic over here. This should work. Yes, okay. But we are going to make it a little bit easier. So we are not patching it vice versa. I just want to show you all or many possibilities to solve this challenge right now. You can also try this on yourself later on, and if you have questions, please write me a message. I'm super glad if I receive feedback on challenges like this, and of course I try my best to help you out on it, okay? Alright, so this will be also an approach that should work. So what's next? Okay, we are in this method over here. Yes, we talked about this one, we end up here. Otherwise, we talked about the true statement. But now we need to go into the false. And the false statement, once again, exactly the same. But okay, now it's a little bit different. Let's see. All right, let's do this. We invoke this method over here, root util check method 3. So regarding to this line and this line, it means one last chance to write it clean. So let's see. v0 is root util check method 3. Then we are having an if statement. If, oh, that's interesting. If v0 is equal 0, we jump to condition 0. Alright, where's condition 0? There's condition 0, nice. This means we are writing 0 into v0. Okay, and then we go to label 1, go to 1, which is this one here, and we are returning out. So we are returning v0. Alright, this is different. Oh, nice. So what do we have here? If this method now returns 0, then this device is being flagged as not rooted. But the thing about this method is we can only reach this method, this point over here, this one, if this one has been false and if this one has been false. Only then we can reach this point over here, which means if one of them has been not false, then we end up here in a rooted device. Alright, so this is how the logic is implemented in Smali. It's maybe a little bit confusing at the beginning, but if you go through this once again and write it down exactly like we've done this on a whole paper completely, then you will realize this, okay, this is how the logic works, and maybe then it's not that hard anymore. I really encourage you to write it down in the following way. Maybe a little bit more clean than I do, and maybe also more complete than I do, but this is a really good approach to understand Smali. Okay, so now let's see. So if this one, then we jump to condition 0. Condition 0 was here, okay. And then from this one, we jump to this one, and we skip this part here. All right. So by looking at this, I came up with 2 additional patching options, or at least one. The other solution I see right now is regarding to the labels. This one, and also this one, for example. So these labels define a branch instruction. We have our code, let's say this one, check, let's call it check, root, and so on. Based on this, there's a decision. If we go on the left one, which is for example true, which is in this case condition 1, device is rooted. Or if we go into false, and then not rooted. This is what we want to have. And this false statement over here is not regarding to condition 1, it's regarding to condition 0. Condition underscore 0. So we can also change the label to achieve this task. But to manipulate the jump instruction to not go into this way, to always go into this way. That's also a really nice solution in my opinion. And feel free and have a try on this one. So the easiest solution I want to show you right now is the following. We've got only 2 Boolean values in our function over here. We've got this one here and this one. This sets the device to false, or not the device, sorry, the routing detection to being false, which means not rooted. This one here sets the device to true, sorry, the routing detection to true, which means the device is rooted. So the simplest way to patch this routing detection is to change this value to 0x0. By doing this, the device will be also not rooted, and therefore we can run our application as a normal app. Alright, the other solution is, let me clear this real quick. Before we return out of this, at this point here, we can apply a new command or a new instruction, which is const /for v0 0x0. So we can simply write this instruction once again just right before we return out of this function. This means no matter what, even if our v0 register is being set to 1 at this point over here, which means true, we are overwriting v0 at this point with false. And then we are returning the last value, this one over here. Okay, so I will show these two approaches in this video right now, and I will make an additional video regarding to patching those jump labels. Okay, so one easy patch is simply this one. I know this is ridiculous, but it should work. If you take a look into this, all methods now return false because there's no option for them to return true anymore. All right, so let's have a look. So ADB uninstall, uninstalled, ADB install, out APK, success, root check. There we go. The device is not rooted, login is now possible. And if we click login, we've got our flag because yeah, we've got some insane Smali skills. Nice. So that's all we need to do. I know it looks super simple and you might think, oh well, was it really that easy? Yes, but we did a lot of work to understand that it's that easy because we reverse engineered this application and figured out what's going on. Okay, in this case, this is a nice trick to check, okay, there are only 2 Boolean states available in here, but this comes with practice and experience in Smali. Okay, so don't worry about this if you've got some really complex or if you put a lot of effort into this. This is absolutely normal and it's not always that easy to patch this. All right, let's revert this change. So now we've got back the original change. If we build this, our device is still being flagged as rooted. The other approach is to introduce a new Smali instruction over there. So just before we turn out, we overwrite this register which returns true or false for this Boolean value. And yeah, let's build this application also once again and install it. I will fast forward this right now. So I will see you in a few moments. And yes, you can see this one also works. Nice. Yes. All right. Let's have a look into the decompiled output. How our routing detection works right now. So this is our patched version. So this is now this version over here. We are overriding the return value with false. Let's see how the Java code looks to this. Root util. There we go. This one has been now added. So no matter what the first output is, it will return false. This is what we have added by introducing this new instruction just before we return out of this function. All right, so this was a really rough challenge right now. Okay, this patch was easy, but understanding what's going on was really not that easy. And therefore, no matter how it worked out for you, if you could solve this or not solve this, and if you also gone through this once again and solved it, no matter if you received some help regarding to the solution video right here, but if you have gone through this and have understood what's going on, and if you have been able to reproduce this, then this belt is for you right now. There you go. Alright, I will make an additional bonus video regarding to this challenge because it was also pretty interesting for me that there are these many options for us already to solve this. So it's really nice to see how many opportunities we already have right now because we are just in the half of the Smali topic. So we get a lot of more power in the next chapter when we talk about methods and also introducing or inserting more complex instructions. So the bonus video will be directly after this video, but if you already have patched this conditional jumps over here, the labels, then you can of course skip this. If you're feeling pretty confident in doing this, of course feel free to skip this. It's not really required. We will move on with objects, which is the last huge chapter in our Smali learning process. And by doing this, we will get even more power in hacking these applications. So I see you there.